We're coming back to annuity. Sorry about I got it mixed up. I thought we'd done it, and that's why I did that different thing yesterday. Now we're coming back to annuity. So I'm probably good to have a bit of a break, because this is a little bit. Okay, so conceptually it's fine. There's a little bit of working out and things like that. So we can use the annuity formula. It's actually a very useful formula that does a whole lot of things. Okay, so what we're looking at today is the present value of annuity. And basically what that means is, if you have a goal for your annuity, let's say for your superannuation, in 30 years' time, at a certain interest rate, you want to have $1 million saved up in your superannuation. You have to put in a certain amount every 2 weeks or whatever. But the present value formula says, at that interest rate, what lump sum would you have to invest today to have that much at the end of 30 years? Okay, so as in the idea being that presently, what do I have that's going to be $1 million in 30 years? Okay, does that make sense? You're saying what lump sum will grow to $1 million in 30 years? And you use the annuity formula in a slightly different way. So sort of adjustment of it using those ideas to find out present value. Okay, which is a lump sum. So we can, but before we talk about it, let's talk about finding repayments. So if you want to know the amount you want to save, okay, so if you have a goal of saying in 20 years I want $600,000, and you know what the interest rate is going to be over that period, and obviously you know the period as well, 25 years, then you can work out how much do I need to pay per time. Alright? And so what we need to do is you actually use the annuity formula and then you rearrange it. So somebody remind me please as to what the annuity formula is so that we all refresh and make sure. So we have, so A equals, in bracket, 1 plus R to the power of N minus 1 over R. Okay, with the curly brackets. So what we can do is if we know what A is, and we know what R is, and we know what N is, then obviously we can work out what N is. And so that's basically what this example is saying. Tristan wants to retire with $1.3 million, $1,300,000. He is retiring in 4 to 5 years' time. Good. If the interest rate is 6.8% per annum, okay, let's say over the life, how much will he have to contribute per year? And so this would be an interesting exercise. If you from now want to have $1.3 million in superannuation to retire with, how much would you have to save per year to get there? That's 6.8% per annum. So what we can do is, well, A is equal to 1,300,000. That's what we know here. It's N equals 45. R equals 0.068. Alright, so we can now substitute all these in to our formula. So now I can substitute it into the formula. I say, well, 1,300,000 equals M, which I'm trying to find, 1 plus R, which is 1.068 to the power of 45 minus 1 over 0.068. Now, the easiest way to do this is to find the value of what's in the brackets. So let's go ahead and do that. Find the value of what's inside the brackets. What'd you get? Yeah, that's right. It's a 269.21. So if let's move that up a little bit for the space. So what we get is 1.3 million equals m times 269.22 divided to 215. How do I find what m is? Yeah, divide both sides by 269, so m equals m equals 1/300,000 over 269.215, and that is equal to find it from my place. Seems to go right. 4,000. So what this means is, if Tristan wants to have $1.3 million saved at this interest rate in 45 years' time, every year you have to put this much away. That's how it's going to build up to. Okay? So that's the way that we work this out. Make sense? Oh, mistake. Right? Now, the next one that I want to have a look at is finding the time period. Why is the pen missing? All right, finding the time period. Oh, that's a good idea. Except I'm going to pick it up. Anyway. Similarly, we can use the future value formula to find the number of time periods required for an investment. So this idea is the unknown here is n. So we're saying I'm willing to put aside this much per period, per month or per year, and I want to get to this much. How long will that take? That's what we're saying. So it's a good way to work out, for example, if you're saving for a certain holiday or a certain value, you're willing to put aside this much. How long will I take to save up at this interest rate? Okay? So let's have a look. We have Ben makes payments of $3,000 at the end of each year. He wants his investment to be worth $200,000 with an interest rate of 12% per annum. How long will he have to wait? How long do you think you'll have to wait, Ben? $3,000 a year, 200 grand. Okay, let's have a look. So again, you use the formula and we say, well, 200,000 is A equals 3,000 is M over 1.12 to the power of n minus 1 over what? 0.12. Okay, you all understand how I get 1.12? I'm just cutting out the 1 plus r. I'm just doing it straight away. So now we have to simplify this a little bit, which we're going to go ahead and do. We need to simplify, put some space in. So, we first need to divide both sides by 3,000. What's 200,000 divided by 3,000? 66.67. 66.67. Probably should keep it to 3 as well. 667 equals 1.12 to the power of n minus 1 over 0.12. How do I get this top by itself? Times both sides by 0.12. So multiply by 0.12. Right, so 66.667 times 0.12 equals 8. equals 1.12 to the power of n minus 1. Then we have to add 1 to both sides. So we end up with 1.12 to the power of n equals 9. Now, we don't do this thing called logs in this course, so we need to do a bit of estimation. So the first person to get an estimate, I'll give a prize to as to what n is closest to. The person who gets closest, we're going to go check for the prize. Go check. Now this is where we get into present value. Okay? The present value of an annuity. The idea of what's the lump sum that it's worth now to get to that value in the future. So if we have a look, the present value of an investment is the single investment amount that would grow to the same value as if regular payments were made at the same interest rate. Okay, so the equivalent of doing the annuity where if you invest this lump sum, how much is it going to be worth? And so the present value formula is n equals a, which is the future value, over 1 plus r to the power of n. So n equals a over 1 plus r to the power of n. Right, that's the future value formula. N's the number of periods, n is the present value, a is the future value. Okay? Making sense? And if you think about it, this is actually the compound interest formula for n, where you divided both sides by 1 plus r to the power of n. Okay, don't worry too much about that. So we're going to just do a couple of examples. So writing down this future value, present value is n equals a over 1 plus r to the power of n. Okay? An annuity over 25 years has a future value of $40,000. The interest rate is 8% per annum. Find the present value. Okay, so the present value, if we use this, is n equals, the future value is 40,000 over 1 plus r 0.08 to the power of 25. As it rains off.
Really?
Not a special. Can somebody work this out? It's meant to be 25. Is that 5,800? Okay, so everyone understand this? That you're dividing the future value by 1 plus r to the power of n. That gives you the present value. Okay? So just be clear what the present value is actually. Conceptually, it's just invest in lump sum. That's what it's going to become in the future at that same interest rate. Okay, so in this case, it's 5,840.72. Now, we come back to this. Now, the thing about it, we can also write the present value formula in a different form. Well, if we insert A from the future value of annuity formula into this formula, then you get a different type of formula, which looks a bit complicated, but it has many uses that then you can work out repayments that you might have to make, or you can also work out loan repayments if you're talking about loans. I'm going to do that now in the examples. So,
Sir, it's not right. What?
can come back to it after.
So, wait.
5,000. Is it not? Hey guys, tuck your shirt in. So we can also rewrite the present value formula in terms of the regular repayments of an annuity. Replace the A with the value from the future value formula. So A is equal to 1 plus r to the power of n minus 1 over r. Should have an m in it, sorry. Should have an m there. And so if we rewrite it like this, this gives the present value formula as n equals n times 1 plus r to the n minus 1 over r times 1 plus r to the power of n. Right? You don't have to memorize this. It's on your formula. However, you do need to know how this can be used. M is the regular contribution. Write this down, please. And then I'm going to give you these 3 examples. I want you to listen to very carefully. N equals M, which is the regular repayments. Remember, N is the present value.
Oh my God. Oh, wow.
Put that away first. Alright, so that's the complicated, fairly reasonably straightforward how to use it. Okay, you got it down? Make sure you get it down correctly. Okay. Some of this. Relax. Amy contributes $250 each month to her superannuation. It earns 10% interest. If it contributes for 15 years, find the present value of the investment. Now this is where you need to, 10% interest is per year. So then we have to work out the monthly interest rate. And we also then have to work out how many periods there are in terms of how many months. So there's a few steps that we need to follow for a question like this. So I'd like you to focus on this, so don't worry, I can come back to this. So monthly interest rate, first. Monthly interest rate is, how do we find that? 10 divided by 12. And what is it, Amy? So 0.83 is fine. 0.83%. Now we have to find how many periods are there in this line. 15 times 12. Okay? So n is equal to 15 times 12, which equals to 180. So the formula will look like this. Bear with me. This is, so remember this is 0.0083 as a decimal. Okay? So n, the present value of this investment is 250 times 1 plus 0.0083 to the power of 180 minus 1 over 0.0083 times 1 plus 0.0083 to the power of 180. Okay. Then we need to work this out. Please everyone do this as well, because you've got to practice being able to do these sort of things. Well, we choose to sit on this topic. I'm just pointing out. did you get? What did you error? What did you get? I got 450 something thousand.
We had 500.
Got 450 something thousand.
What did
So as you can see, go to the last example. So this one, that's the formula applied, and it's $457,084. Okay? So remember, that's saying that's how much you have, that's equivalent to how much you have to invest now at the same rate for those 15 years to have however much is going to happen. So that shows the power of annuity in terms of the growth that you can actually achieve. Okay, so you're actually saying that in terms of lump sum, in a sort of funny way, you have this much money at the moment. Because in 15 years, you're going to have a huge amount when you work out what the future is. Alright? So, I'll just put it up here. So we can also use the present value formula of an annuity to work out loan repayments for a loan with given amount, rate, and time period. Okay, this is a good application of this as well. So if you know how much you borrowed, you know the interest rate, and you also know the time period, how many years, then you can work out the monthly repayments or yearly repayments depending on when you contact. Okay? So we're going to have a look at this example. So you're going to just bear with me for a second. I'm going to move it up and come back. Okay? So let's have a look. Nick borrows $250,000 at 6.5% per annum for 30 years. How much is each monthly installment and how much is paid back altogether? Alright? So what we do with this is we say, well, N is equal to 250,000. Alright? R, we have to find, is equal to 6.5 divided by 12. What is that? 6.5 divided by 12. 0.54. Good. 0.54%. And N, the small n, is equal to 30 times 12, which equals to 360. Alright? So that's equal to 0.0054. Now, again, we've got all the parts that we need. So what we're trying to find is M. So we need to say, well, 250,000. So you get the idea that what you're saying is the present value of this loan is 250,000. That's how much we borrow. And it's going to be more in the future because you have to pay back interest. Alright? So $250,000 equals M times 1 plus 0.0054 to the power of 360 minus 1 over 0.0054 1 plus 0.0054 to the power of 360 equals, we're going to get M times something in brackets. So what do we get? Yeah, I would suggest you do that. There is a way you can flip it over and multiply this side, but it may be a little bit more complicated. So again, you've got to see if we can do it. So 1, 2, 0.0054 to the power of 360 minus 1 divided by 0.0054 times 0 times 1.0054 to the power of 360 equals, what did you get, 158? 158.54. Okay, and so the final step is we have to divide 250,000 by 154. So M equal to 250,000 divided by 158.54. That equals 1. This is the monthly installment that he would have to pay for the life of the loan, $1,578.89. This is monthly repayment, gets 360. Total amount paid back $1,578.89 times 360. $567,680.10. So you get an idea that over the life of the loan, he's borrowed $250,000, but he pays back $560,000. More than 200% of what he's borrowed. And this is only for how many years? This is for 30 years. Okay, so that's a fairly standard sort of life of the loan. So if you borrow $800,000, it's going to be that much more. Alright, so it gives you an idea that loan repayments take a big hit in interest as you're paying it. Exercise 5.8. Please start doing it. Have